worksheet. Some of them are a little tricky. Let's see. That's the wrong one. There we go. All right, so first thing are characteristics of an ideal op amp. So I went over this at the last session, but there's likely going to be a pretty basic op amp question on your test, and it will be an ideal op amp, and so you'll need to know the characteristics of an ideal op amp. So do you know any of those? Okay. Okay. All right, so the voltages at the inverting, so that's the negative, and non-inverting, that's the positive, terminals are the same. So we often just say V plus equals V minus. And so those have to be the same. They don't have to be zero, but they have to be the same. Okay, then we have that the currents into those terminals have to be zero. So I plus has to equal I minus, and those both have to equal 0 amps. So those have to be the same, and they have to be 0. I'm trying to think what else. So the others I don't think are as important for solving the ideal amp problems. The internal resistance is infinite, but that's just because that's what you use when you say that the currents into them are 0. And we'll see how we use this when we do some examples. So that's the main thing. So right there. All right. So let's go on to number 2. So these are these non-periodic waveforms that start the chapter that y'all are working on now. So, and these functions have different names in addition to the ones that are used here. And off the top of my head, I can't think of the other name for the unit ramp function, but I know it has one. Let's see. Well, maybe it is just ramp, maybe it doesn't have another name. Okay, so I just can't think of it. I thought it had another name, but I can't think of what it is. Okay, so describe and graph the unit step function, unit ramp function, and the rectangle function. Okay, so these are used a lot, and you'll see this unit step function a lot for the rest of the semester, because it describes a function so the unit step function which your book uses U of t. You'll see some books use theta of t. So unit step function is 0 for when time is less than 0, the unit step function equals 0. And for time greater than 0, the unit step function equals 1. So it's basically an on switch. So it's 0 until you get to 0, and once you get to 0, it becomes 1. And so you can use it with other functions. So I could define a function like this: f of x equals u of t times x squared. And what that does for me is it says, okay, my function is 0 all the way up to when time equals 0, but then after that, it's x squared. So it's like it can be used to like turn something on, or you could use it to turn something off if you wanted to. If I had u of minus t, what that looks like is it's 1 when time is less than 0, and it's 0 when time is more than 0. So u of minus t is 1 until you get to 0, and then it's 0 after that. So one way you could use that is I could have f of t equals u of t times 3t times u of t minus 2. So let's think about what that would do. So let's think about u of t. What u of t looks like is 0 until you get to 0, and then it's 1. And then 3t looks like this. Oh, I meant to say u of minus t minus 2. U of minus t minus 2. So u of minus t is the one that we did right here, but u of t minus 2 shifts that one to the right by 2. Actually, that's not right. I want u of minus u of minus t minus 2. So what that does, when I have u of minus t minus 2, so u of t minus 2 shifts it to the right by 2. So u of t is 0 and then 1. U of t minus 2 shifts it to the right by 1. But then u of minus t minus 2 then reflects that whole thing, so then it becomes that. Make sure that's right. Yep. Yep. Yep, that works. Okay, so now let's look at our three functions together. So u of t is 0 until we get to 0. So if I multiply that times anything, I know I'm going to get 0 until we get to 0. So it'll be 0 all the way until 0. And then between 0 and 2, I have my other unit step function as 1. So I would just multiply my 3t times 1, and so between 0 and 2, I just get 3t. And then after 2, it's 0 again, and if you multiply by 0, you get 0. So it just turns it off. So using these two functions, this says you turn it on at 0 and you turn it off at 2. So that's just how you can use the unit step function. Okay, now the unit ramp function. Oh, one last thing with the unit step function. So 5u of t, all that does is multiply it by 5, and so you get to 0, 1, 2, 3, 4, 5, and then it goes up to 5. So that's 5u of t. So the ramp function is 0 for t less than 0 and t for t greater than 0. So t is just the line y equals x, just the diagonal line. So the ramp function just looks like this. And so if I had 2r of t, then that would have a slope of 2. So the ramp function gives something a slope. So that would be that one. The rectangle function is kind of weird. You don't see it used that often, and it's often just called a pulse. And the rectangle function, they write it like this. We have rect t minus capital T over the Greek letter tau. So this is a rectangle centered at T with width tau. So for example, if I had the rect of T minus 4 over 2, and it's going to be 0 everywhere else. So 1, 2, 3, 4, 5, 6. Okay, so it's centered at 4, and it has width 2, and it'll have height 1. So it goes like this. So 1, 2, 3, 4, 5, 6. So it starts at 3 and ends at 5 because it has width 2. And I should put in my emails that this building is freezing. It's so cold. So why don't you see if you can draw this one? See if you can figure out how you would draw that one. Hey, how are you? Well, I just went over all of the questions that are going to be on your test next week, and you just missed it. I didn't record it. Here. I'm lying.
I'm surprised nobody else showed it.
Yeah, I am too. I think I was talking about that earlier. I think it's people are used to sleeping in because it's like maybe they don't have another class today. I don't know.
I'm just sleeping in today.
Yeah.
Because I don't have class till 1:30.
Yeah.
So.
Yeah. Well, thanks for coming. I appreciate it. Okay, so this one has, it's negative, so it'll be below the axis. Did you get a chance to try it yet? Okay, and so,
I turned my thing too low, so I'm like going all over it.
oh. So where is it centered?
Is that two?
It's actually centered at -2, yeah, so centered at -2. And it has width 4, so it goes over to 0 and over to -4. And then it's negative, so it looks like that. Okay, so what we just went over so far were we just reviewed the characteristics of an ideal op-amp, and then we discussed what the unit step function, the ramp function, and the rectangle function are, but we haven't really done much with them yet.
Okay.
So that's,
I'm mainly here for the op-amp.
okay, all right.
I'll see you laptop stuff.
About to die? Is it not plugged in? It's not plugged in. Did I bring my charger? I thought I did. I didn't. Would you?
Yeah, I can be.
Okay, it should be like right behind my desk.
Okay.
The recording. Okay, so -6u of t minus 3. So that's the unit step function. It's shifted to the left by 3. And the -6 means that when it gets to -3, it'll take on the value of -6. So less than -3, it'll be 0. And then when you get to -3, it becomes -6. And then that's what it is. Okay, this next one, we're combining two unit step functions. So I'll have 2, 4, 6, 8, 10, 12. And 1, 2, 3, 4, 5, 6. Okay, so when I have multiple functions, I look for the one that comes first, and that's the -2. So that means that it's 0 all the way until I get to 2. Once I get to 2, it jumps up to 8. And then it stays at 8 until the next thing happens, which is at 4. And at 4, I'm going to add 2 more to it. So then it'll be at 10, and it'll look like that. Now, what ramp functions do, when you add and subtract ramp functions, what you're doing is you're changing the slope. And the slope is the number that is in front of the ramp function. And so for C, we have our first thing happening at -2. And at -2, we have the ramp function 5 times the ramp function, so that's a slope of 5. So when I get to -2, so it's 0 until we get to -2. And then once I get to -2, I have a slope of 5. So if I go over 1, I go up 5. 1, 2, 3, 4, 5. 5. And then one more, I'll go up 5 more. 6, 7, 8, 9, 10. And then when I get to 0, I have a slope of -5. So what that does is it takes my slope that I had before, which was +5, and subtracts 5 from it to give me a slope of 0. So it just cancels out that slope.
So
Yeah.
you did it, like you added a slope on purpose, like it didn't just go, like jump up, like there's like a right-hand on this.
So what I did was not. Tell me if this answers your question. So it started at -2, and I knew it had a slope of 5.
And a slope.
Had a slope of 5, and so that means you go over 1, up 5. So I went over 1 and up 5, and then over 1 and up 5 more. Does that answer your question?
Yeah, that
Okay.
answers my question. So normally whenever it's like 5r t plus 2,
Mm-hmm.
would it just keep going up?
Yeah. So if I had like 2rt plus 1, for instance, then it would be 0 until I get to -1. And then I would have a slope of 2. And it would just keep going up. But if I had 2rt minus 3 plus -1rt minus 2 minus 2r of t, what that one would look like would be when I get to, it's 0 until I get to, 0 until, oh, I put these backwards. Okay, so it's 0 until I get to 0, and then I have a slope of -2. So and then when I get to 2, I'm adding on a -1 to my slope, so now I have a slope of 3. So I'll go, for my next one, I'll go down 3. So I got slopier. It's hard to tell, but. And then when I get to 3, so I had a slope of -2, then I subtracted 1, I have a slope of -3, and when I get to 3, I'm going to add 2, and so now I'll have a slope of -1. So it has, the slope is changing. Okay, now I have 5rt plus 2. Can y'all tell me what the rest of it was?
5rt plus 2 minus 5rt of t minus 10ut.
Okay, so the minus 10u of t says when you get to 0, you're going to shift everything down by 10. So 5rt plus 2 says when I get to -2, I'll have a slope of 5. Minus 5r of t says when I get to 0, I'm going to subtract 5 from my slope, so I have a 0 slope. But the minus 10u of t says I'm also going to drop down by 10. So it'll look like that. So the minus 5r of t got rid of the slope. The minus 10u of t brought it down by 10. And then 10 rect t minus 1 over 2. That was D.
Okay, so how come, if we're adding up the slopes,
Uh-huh.
how come the 5r's just don't cancel out with each other?
They do, and you get a slope of 0.
Yeah, but then the -10. Oh wait, never mind.
That-
Yeah, never mind.
That's, yeah,
That's not a slope.
that's not a slope. So 10 rect t minus 1 over 2 plus minus 5 rect t minus 3 over 2.
I'm sorry, but also, wouldn't it get brought down to -10 then for D?
No, because it subtracts 10 from where you are.
Oh. Okay, never mind.
No, those are good questions. I'm glad you asked, because usually every year people ask those questions and there just aren't that many people here, so, yeah. Yeah, so you want to be careful about that. Okay, so this first one says I have a rectangle centered at 1 with width 2, so it goes over to 0 and over to 2, and has height 10. So I have that rectangle, and I have 0 before that. Oh wait, this other one was supposed to be t minus 3 over 2. I think I copied that wrong. Let me change that to t minus 3. No, that's right, t minus 3 over 2. So it's centered at 3 and has width 2. So centered at 3 and has width 2 and has height -5. So that'll go over to 2 and over to 4 and down to 5. So it'll look like that. Usually, instead of calling things the rect function, they just call them part of a square wave. And so you'll see that in electronics. Okay, so now we're into the op-amp question. I'm being very brave here because this is not one I've done before. I supposedly have the solutions, but I don't know if I trust the book I got it from. So let's see how we do. All right. Did I have like an instruction on this? Did I say to find V out? Okay. All right, so what we know is that V minus has to equal V plus, and we know I minus has to equal I plus has to equal 0. So we know that any current entering into these terminals is 0. So that current is 0 and that current is 0. So that also tells us if I'm looking at V minus, I know that the current here all the way through there has to be the same because none of it can branch off and go into the op amp. So if I say the current is going in this direction, then I can say that I equals 0 minus V minus over 4K. And I can also say that I equals V minus minus V out over 2K. That's the same thing that I would get if I did a nodal analysis equation of starting at V minus. So starting at V minus, I'd get V minus minus 0 over 4K plus V minus minus V out over 2K equals 0. And those two things are identical. So I get that. So what this tells me is if I multiply everything here by 4K, I get V minus plus 2V minus minus 2V out equals 0, or 3V minus equals 2V out. So I kind of have that relationship. Okay, so now let's look at our non-inverting input and see what we've got. So I can say that starting at V plus, I would have, I'll move this down. Starting at V plus, I have the current going up from V plus is 0, so I can ignore that. I can say V plus minus 6 over 6K plus V plus minus 0 over 12K plus V plus minus V out over 8K has to equal 0. Write this perhaps a little neater. I can multiply through by 1,000 and get rid of the K's. I can make the numbers a little smaller by multiplying through by 2. Okay, so now I'll multiply through by the common denominator, which is 12, and I get 4V plus minus 24 plus 2V plus 3V plus minus 3V out equals 0. this is where I make mistakes, so y'all make sure that I'm do my math right. 4 plus 2 is 6, plus 3 is 9. 9v plus minus 3v out equals 24. Three v plus minus v out equals 8 if I divide by 3. And then we know that v plus equals v minus, and we know that v minus, 3v minus is 2v out. Our v minus is 2/3 v out.
When you were up there,
Oh.
where did you get the 12 from?
I got the common denominator of 3, 6, and 4.
Oh.
I was just getting rid of the fractions. So v plus is 2/3 v out. So 3 times 2/3 v out minus v out equals 8. That's 2 v out minus v out equals 8, or v out equals 8. That's what my answer sheet says. V out equals 8 volts. Now, one thing that bothered me, and I looked it up to figure out why it was, is I don't know if this is going to happen on this circuit, but it does happen on so what happens is if this is 8 and V plus is 2/3 of 8, what is 2/3 of 8? Can somebody calculate that?
It's gonna be a weird number.
Yeah, it'll be a weird number. $5.333. Okay, now that would mean that the current here is 8 minus 5.333 divided by 8 kiloohms. So the current here would be 333 milliamps. Wait. Eight minus 5.33333 divided by 8,000. No, it'd be 0.33 milliamps. So 0.333 milliamps. And then the current going down here would be 5.33 divided by 12,000. Which is 0.44 milliamps. And the current going in this direction, actually it'd be the current going in this direction, would be 6 minus 0.5333 divided by 6,000, which is, well, this one works, as I would expect it would, because so I have 0.111 coming in, 0.333 coming in, and 0.444 going down. I have seen problems where you end up with, it seems like there must be some current going into the op-amp. So anytime you're trying to find the current going in a particular direction across a resistor, it's the voltage from where you're starting minus the voltage where you're ending over the value of the resistance. And so, and that's just always, almost always gonna be the best way to do it. So what I did up here is I said, well, we found that V out was 8, and we found that V plus was 5.33. So to get this current, it took 8 minus 5.33 divided by 8,000.
You just go in like the way the current's flowing.
Yep, yep. So like if I want to find, so if I draw the current in this direction right here, and I label it that way, and I want to find I, then I would take 0 minus V minus, which we said was 5.333, over 4 kiloohms, which gets us 1.33, negative 1.33 milliamps. And that's fine. It's saying it's negative, it just means it's really flowing the other way. So. Now, you'll notice what that means is we have 1.33 milliamps going this way, and we have 0.33 milliamps going that way. Whereas that current coming from, that's coming from the op amp. All right. Let's see what's next.
So usually, like, the best thing to try out first is an analysis for op amps.
It's what tends to work for me is nodal analysis, yeah. Okay, we'll see if this problem works. I made it up. So it says graph Ix as a function of time. And the current source is given as a unit step function. So the current source equals 0 until t equals 2, and equals 2 amps for t greater than 2. And you're going to be working with a lot of circuits for the rest of the semester that have that are switched on or off like this. And so you have to look at them in two different times. So we would say before t equals 2, our circuit looks like this. Because before t equals 2, there is no current source. So in this case, I will equal VR, V equals IR, I equals V over R. I will equal 12 over 7. I should have picked a better number. If I make up a problem, I could have made up something nicer. And 1.71 amps. After t equals 2, it looks like that. And I'm looking for the current through this branch. So I know the current coming into that node is 2. So if I do a nodal analysis right there, I would say V minus 12 over 5 plus v minus 0 over 2 equals 2. And then I'll multiply everything by 10 to get rid of the fractions. So 2v minus 24 plus 5v equals 20. Or 7v equals 44, or v equals 6.29 volts. So if V is 6.29 volts, then the current going through that branch is 6.29 minus 0 over 2, which is 3.14 amps. So I have that it's 3.14 amps after time t equals 2, and it was 1.71 before time t equals 2. So it looks like this. So 1.71.
What's the cut again?
The second time,
Yeah.
3.14. Which I would like to say I made it on purpose to be pi, but I didn't. So it would just look like that.
You still think that would be interesting.
Mm-hmm.